Hi, in the sixth part I will continue with the arithmetic addition commands, precisely the add with the carry flag and the 16-bit addition. After a suggestion in the command section, I will split the Intel from the Zilog part, so if you want to skip the Intel part, click on the link in the description. Let's start with the Intel. In this example, I want to add two 16-bit numbers. The first one is defined in the double register D. The next one in double register H. So we want to add both 16-bit numbers and put the result in HL. First, we have to add the low byte. So the low byte of the first 16-bit number is register E with register L. Let's do it. The addition commands does only work with the accumulator, so we have to put, for example, E in register A and then add register L and putting the result from the accumulator back to L. Okay, the next number would be adding D with H, so I have to move D to A, adding H, and putting back the result from the accumulator to the register H. Okay, so A is, the accumulator is loaded with 3, 4, adding L, 8 and 4 is 12, that's C in hexadecimal, and 7 and 3 is 10 equals A, so result will be AC. Putting that back to L, loading the next number, D, adding 56 to it, 6 and 2 is 8, and 1 and 5 is 6, 6, 8. That's a result. Let's do a quick check in the calculator. So hexadecimal, 1, 2, 3, 4, and adding 5, 6, 7, 8, 6, 8, AC. Okay. Now, if we change 3 with F, reassembling the code, four and 8 is a C, F and 7, well, F is the last digit, so there will be a carry. After F there's 0 again, so it will be 6C, 6C, and even after the addition, the carry flag is still set. That means that you have to add 1 in the next addition command. In our case, we haven't done it, so the result will be wrong. Um, 12, 2 and 6 is 8, and you have to add 1, which is not the case now. So the result will be wrong. Let's check it with the calculator. 1, 2, F4. So the result should be 696C. Let's correct this. So here in the last add, we have to use the command add with carry. The add with carry is the same as add. You can use it with A, B, C, D, E, H, L, and also the memory register. Let's do it again. So carry is set. Now 2 and 6 is 8, but it's an add with carry, so you will add 0 or 1, in this case 1. 69, and the result is correct now. It makes only sense to use an add with carry only after an arithmetic operations. Because if you use it here, add with carry, we don't know the status of the carry flag. That's the first arithmetic operation. So it will add, in this case, 1. And the result is 60. That's already wrong. So you can't use add with carry in the first arithmetic operation unless you clear the carry flag. But unfortunately there's no command to clear the carry flag on the Intel 8080 or 8085, but there's one to complement the carry flag. Complement means if it is 1, it will be 0, and if it is 0, it will be 1. And luckily there's one to set the carry flag. Set carry flag. Let's give it a try. Setting carry flag. Well, flag is already set, so it won't change here. And complement carry flag, it will invert the carry flag. We'll set it to 0, so now add C will be correct. There's another add with carry command, and that's the ACI, add carry immediate. So you add a value, for example 1. So A is 1, ACI is 2, would be 3, but the carry flag is set, so it will be 4. Okay. How can you improve the 16-bit addition? There's a far easier way to do it on the 8080 or 8085, and that's a double add command. In this case, double add D. So D is loaded, H is loaded, and DHD will add the double register D with HL and put the result in HL. Here we go. That's it. There is a double at B, and double at D, and double at H, and a double at stack pointer. So for example, if you have here B, place it here B, B is added to HL, if you're doing double at H, it will just double the result. If you want to know the value of the stack pointer, you set the double register H to 0 and just double add the stack pointer to it. So stack pointer has a value, HL register is 0, you double add it, that's the value of the stack pointer. If you want to see the same examples in Z80 mnemonics, stay tuned. Otherwise, please click the link in the description to participate in the poll. Thank you. Welcome back to the Z80. I will do the same examples as before. I want to add two 16-bit numbers. The first number is in DE and the second one in HL. So we want to add the number in DE to the number in HL, and I want to put the result also in HL. We can do only the addition in the accumulator, so we have to move. We have to start with the low byte. We have to add E with L, put the result in L, and then the high byte, D adding to H, and putting the result to H. Let's start. So I'm loading the low byte from the first value to the accumulator, adding L to it. I'm putting the result back to L, loading the high byte value, that's D, adding H to it, and then loading back the result to H. So loading E with the value A, the value from E to the accumulator. So the next command is adding L to the accumulator. 8 is added to 4. 8 and 4 is 12. It's C in hexadecimal. And 3 and 7 is 10. So the result is AC. Then putting AC to L. Then loading the D to accumulator and adding H to it. So 2 and 6 is 8, and 1 and 5 is 6. 6, 8. And the result is 6, 8 AC. Let's check it in the calculator. 1, 2, 3, 4, 5, 6, 7, 8. We are in hex format, yeah. That's 6, 8 AC. You can see the carry flag is not set when you add these values together. But what will happen if we change 3 with F? So 4, we're adding 8 with L, 4 and 8 is C, and F and 7, F is the last digit, so there will be a carry. That means F0, it's, and 7 is 6, 6C, and the carry flag is set. That means you have to add 1 in the next add command. In this case, we haven't done it, so the result will be wrong. Let's check it with the calculator. 1, 2, F4, 5, 6, 7, 8. The result should be 6, 9, 6C, and we have here 6, 8, 6C. To correct this, we have to use here the add with carry command. Okay, the carry is set, and here we are adding H to A. 6 and 2 is 8, plus the carry. In this case the carry is 1, so it will be 9, and 1 and 5 is 6, 6, 9, and the result is correct. The add with carry is exactly the same as a simple add, so you can use it with A, B, C, D, E, H and L, and the memory address, and also IX plus a positive or negative index, and also IY plus positive or negative index. It's not a good idea to use an add with carry for the first addition, because you don't know the value of the carry flag. So if we change here add with carry, and here it will add L with accumulator, so 4, and L 4 and 8 is C, and the carry is in this case 1. So the result is already wrong. In the Z80 you can't clear the carry flag, but you can set it. So with SCF, set carry flag, you set a carry, and you have the possibility to complement the carry flag. Complement means 0 will be 1 and 1 will be 0. Maybe makes sense to put that before. Yeah, that's better. So setting carry flag. Carry is already set, so we will set it again, and we will do a complement. Carry flag is 0, and add with carry is now correct, 6C. There's another command to add with carry, and that's the add carry and the value. So we have, for example, 1, add carry with 2, so 1 and 2 is 3, adding the carry, in this case it's 1, so it will be 4. The result is 4. A more simple way to do a 16-bit addition is using the command add HLDE. So DE is loaded, HL is loaded, and the command add HLDE will add DE to HL. 696C. That's it. So add HL exists with PC, the E, HL, and the stack pointer. So for example, here you can put HL, and here we're using BC. BC is loaded, HL is loaded, adding 696C, adding HL, it will just double the value. An easy way to find the value of the stack pointer, let's specify a stack pointer here, is to set HL to 0 and then adding the stack pointer to it. So HL is 0, stack pointer has a value, we're adding it to HL, so the value of HL is now the value of the stack pointer. In the Z80 you can also use the IX register to add 16-bit values with PC, with the E, but not HL. You can add the stack pointer, and you can also add the IX to IX, but not IY. Let's give a quick check. Yep, and the same goes for IY with PC. Add IY with the E and add IY with the stack pointer, and also add IY with IY. The Z80 has 4 more commands. That is add with carry, HL, PC, add with carry, E, add with carry, HL, and add with carry HL and stack pointer. So it will also add the carry flag to the 16-bit operations. That's all for the addition commands. In the upper right corner you can participate in a poll. Do you prefer when I switch between the CPUs like in the previous videos? Then choose Intel and Zilog, or do you prefer how I did it in this video, then select split CPUs, or if you prefer separate videos, then select separate videos. Please use the info box in the upper right corner. I hope you enjoyed this video and stay tuned for the next part, which will cover the subtraction commands. See you, bye bye.